All right, so we are on our last target for Key Concept 7. This is interpretation and representation of linear systems, and we're going to roll it all into one video again. So your learning goals: I can identify a true statement given a graph, determine how many solutions a linear system has based on the worked out solution, determine the exact solutions of a system when given a graph and when given a system, and finally solve a system representing a real-world scenario and determine what the solution means. So, things you're going to want to remember from last targets. When you're trying to solve for variables, if you can solve for both the variables, there is only one solution. Okay, so if you can find an x and a y, there's only one solution. Now, if you go to eliminate a variable and you end up eliminating both, and what you're left with is the same number on either side of the equal sign, could be 0 equals 0, could be 3 equals 3, whatever it is, there are infinitely many solutions. And I misspelled that word. And then finally, if you do the same, except now you don't have two numbers that are the same, you have one that's like 0 equals -3 or 4 equals 9 or whatever, there are no solutions. Okay? So keep that in the back of your mind. Take notes on that of those situations. First example, we're given a graph. We need to identify which of the following is a true statement. Supply of slices of cheese pizza will always be higher than demand regardless of price. Well, supply is higher here, yep, sure is, but supply is lower than demand there, so that one is not true. Supply and the demand of pizza supply and demand are even when there are 800 slices of pizza. So if we look, quantity is 800. Are they the same? No, that's not true either. When the price of a slice of cheese pizza is $1.50, the supply and the demand are the same. So if we go and we look at where the price is $1.50 and we go over, supply and demand are in fact the same. So that one is true, and we want to just make sure that that's the only one. So we're going to go through and just the price for a slice of cheese pizza is $2.50. Well, price is all over the place, so that's not true. And then after 1,000 slices, demand will always be higher than supply. At 1,000, demand is actually lower than supply. Pretty straightforward, just read the graph. Second example, we solved a linear system and got the equation -2 equals -2. How many solutions does this linear system have? Solution has infinitely many solutions, and that's because the two numbers are the same. So remember what I said, if you have two numbers that are the same and they're set equal to each other after you solve it, there are infinitely many solutions. So if you didn't take the notes down from the third slide, you might want to go back and do that now. Next example, we want to determine the solution or solutions to the following system. So remember, solutions are where your graphs intersect. In this case, it intersects in two places, so they are both solutions. So all you need to do is look and see where those points of intersection are. We have -3, +4, and 2, -1. Those are your points. So you're just looking for where the graphs intersect. Next example, let A be any real number. Will the system below always, sometimes, or never have a solution, and explain. So we want to go ahead and we want to make them so that both of them have a y that is on one side of the equal sign by itself. So I need to go ahead and take that top equation and add 4 to both sides, and I end up with y equals ax plus 4. Now notice that this and this are exactly the same, and because they are exactly the same, the system will always have a solution because the two equations in the system are identical. If they were different, then they would never have a solution. Okay? If it was a different letter in front, there could be sometimes, I don't know, it would depend. But in this case, it's always, and if it was, say it was, you ended up with y equals ax minus 4 and y equals ax plus 4, because these are different, this one would never have a solution. Just a second example. And last examples. We have 2 recording studios, and they have cost functions. URapid has a $250 production fee and a 45-cent per song download. Be a Celeb has a $125 production fee and a 65-cent per song download. We want to determine what the solutions of the systems of equations mean. So because we're looking for a solution, we need to figure out how we're going to do this. We can either, get our s's over to the other side, or recognize that they are both equal to c, so we can set them equal to each other. Get your variable on one side, constants on the other. So I'm going to go ahead and subtract 0.45s from both sides, which will give me 250 equals 0.2s plus 125. Then subtract 125 from both sides, which will give me 125 equals 0.2s. And then divide both sides by 0.2, which will give me 625 is my s. Now, just like we've done, go ahead and plug that back into one of the equations. Doesn't matter which one. I chose the top one. So 0.45 times 625 plus 250 equals 531. So what does that mean? That means that at both recording studios, the cost is $531.25 when you download 625 songs. So we need to include this and this in our explanation. So what is this? This is our cost. S is songs. So it's just, you need to incorporate that into it, and it just means that when you find a solution for a problem like this, it means that the cost is the same, and what is that cost, and then relate it to that other variable. Okay? So if you have any questions on this, hopefully you've taken good notes, but feel free to ask questions when you come into class. That is it.